E-Content Development Course, Business Research Methods Topic, Probability Sampling Techniques. Objectives, times to know the simple random sampling and its techniques, times to describe systematic random sampling method, times to understand stratified random sampling method, times to explain cluster sampling method, times to describe the multistage sampling method. In the previous episode, we have learnt some basic terminologies which are used in sampling, such as sample, sampling frame, universe, population, sampling design, etc. In this episode, we are going to learn about the probability sampling techniques. For better understanding, this episode is divided into 5 sections. Namely, Section 1 deals with simple random sampling method, Section 2 is about systematic random sampling method, Section 3 describes stratified random sampling method, Section 4 deals with cluster sampling method, and Section 5 describes the multistage sampling method. Introduction. Sampling is the statistical process of selecting a sample for making observations and to draw statistical inferences about the population. The researcher cannot study entire population because of cost constraints and feasibility. Hence, we must select a representative sample from the population of interest for observation and analysis. It is extremely important to choose a sample that is truly representative of the population, so that the inferences derived from the sample can be generalized. There are number of sampling techniques are available to select a sample from a sampling frame. These sampling techniques can be grouped into 2 broad categories. They are 1. Probability sampling techniques. 2. Non-probability sampling techniques. Probability sampling techniques. Probability sampling is a technique in which every unit in the population has equal chance of being selected in the sample, and this chance can be accurately determined. All probability sampling methods have 3 attributes in common. Times every unit in the population has a known non-zero probability of being sampled, times the sampling procedure involves a random selection, and times sample statistics such as sample mean or standard deviation are unbiased estimates of population parameters. Probability sampling techniques can be further classified into 5 major categories. They are times simple random sampling method. In this method can be further classified into 2 methods. They are O simple random sampling with replacement and O simple random sampling without replacement, times systematic random sampling method, times stratified random sampling method, times cluster sampling method, and times multi-stage sampling method. Simple random sampling method. In this technique, all possible subsets of a population are given an equal probability of being selected. Features of simple random sampling. Times easy to understand. Simple random sample is easy to understand and to implement it. However, it requires a list of population elements and it can be time consuming and expensive. Times larger sample size. Simple random sampling can require larger sample size than other probability methods. Times lower precisions. Simple random sampling often results in lower precision with larger standard error than other probability sampling techniques. Although samples drawn will represent the population well on average. Times appropriate for small population. Simple random sampling is appropriate for small population, but when the population is large, this method becomes cumbersome. Because numbering all the elements in the population and then selecting items is not an easy task. Ways to select the unit of the sample. To draw a simple random sample, the researcher first compiles a sampling frame in which each element is assigned a unique identification number. The selection of the unit of the sample can be done in two different methods. They are times using random number table, if the selection of sample done manually, times Monte Carlo simulation technique, if the selection of sample done using computer. The sample is drawn by a random procedure from a sampling frame. This method is equivalent to a lottery system in which names are placed in a container, the container is shaken and the name of the winner then drawn out in an unbiased manner. There are two ways of performing simple random sampling. There are two ways of performing simple random sampling, namely times simple random sampling with replacement and times simple random sampling without replacement. Simple random sampling with replacement is the purest form of probability sampling method. In this method of sampling, each unit of the population has the equal probability of being selected as unit of the sample. Suppose a researcher wants to conduct a survey related to employee job satisfaction of 800 employees in a company. If the researcher wants to select 10 employees out of 800 employees through the simple random sampling method, then he can adopt simple random sampling technique with replacement. Now let's understand the procedure for selecting 10 employees as sample units. Let the total number of employees in a company be n. Size of the population is equal to 800. Sample size or number of samples are to be drawn from the population, n is equal to 10. Therefore, probability of selecting any set of n units out of total of n units in sampling frame is equal to sample size population size, 10 800 is equal to 0.0125. Steps are to be followed to select sample from the sampling frame. Step 1. Assign each element within the sampling frame a unique number from 01 to 800. Step 2. Identify a random start from random number table. You may ask how to start randomly. You just drop a pencil point on the random number table with closed eyes. Let's say the pencil dot lands on the 7th column from the left and 2nd row from the top, marking the 5-digit number 27982. Step 3. Then decide the direction of movement for selecting the next number, either to the right or below with reference to the current position in the random number table. In our example, considering the three rightmost digits, 982, and going down the column until you get 10 random numbers between 001 and 800. Therefore, the identified random numbers are 982, 179, 440, 468, 602, 194, 595, 740, 867, 865, 663, 320, 689. Step 4. Numbers outside the range are ignored. For example, 982, 867 and 865 are not in our sampling frame. Hence, we just ignore it. Step 5. Out of 800 employees, 179th, 440th, 468th, 602th, 194th, 595th, 740th, 663th, 320th, and 689th employees are being selected as final sample respondents. Now let's move on to understand simple random sampling without replacement. Simple random sampling without replacement. In this method of sampling, each unit of the population has a varying probability of being selected as unit of the sample given by the following formula. The probability of selection of the first unit is equal to 1/n, 1/800 is equal to 0.00125. The probability of selection of the second unit is equal to 1/n, 1799 is equal to 0.0012515. The probability of selection of the third unit is equal to 1/n, 1798 is equal to 0.0012531. Therefore, the probability of selection of nth unit is equal to 1/n, n1. The key difference between these two methods of sampling is the value of probability of sample selection will be constant, i.e. 0.0125 in simple random sampling with replacement method. On the other hand, the value of probability of sample unit selection will vary from one to another unit in the without replacement method. This method uses Monte Carlo simulation technique for the selection of units of the sample from the population. In short, the procedure for drawing probability samples by using simple random sampling method: Step 1. Select a suitable sampling frame. Step 2. Assign a unique number to each element in the sampling frame. Step 3. Arbitrarily select the beginning number in random numbers table. Step 4. Then proceed either up or down until the n different numbers have been selected. Systematic sampling technique. In this technique, the sampling frame is ordered according to some criteria and elements are selected at regular intervals through the ordered list. Systematic sampling involves a random start and then proceeds with the selection of every kth element. In systematic sampling, sample elements are selected from the population at uniform intervals in terms of time, order, or space. This is a special kind of random sampling in which the selection of the first unit of the sample from the population is based on randomization. The remaining units of the sample are selected from the population at a fixed interval of k, where n is the sample size. Let the size of the population, n, be 800 and the sample size, n, be 40. The units of the sampling frame are divided into k number of intervals based on the ratio nn. Therefore, sampling interval width, k, is equal to size of the population, n, sample size, n, is equal to 800 divided by 40 equals 20. Sampling frame consists of units with serial numbers from 001 to 800. This range is divided into 40 intervals with 1 to 20, 21 to 40, 41 to 60, where the total number of interval is equal to the sample size. Then a number from the first interval 1 to 20 is selected randomly and the unit of the population with this serial number is treated as the first unit of the sample. Let the randomly selected unit from the first interval of the population be 13. Then the second unit of the sample is the unit of in the population with serial number 33, which is obtained by adding 20 to 12, 20 plus 12. Then each of the remaining units of the sample can be obtained from the population in the same manner by adding 20 to the serial number of the previous unit selected from the population. As per these guidelines, the units of the population with serial numbers 53, 73, 93, 773, 793. For obtaining starting point or starting number, a random number table can be used. The advantage of this sampling method is that, once the first unit of the sample is randomly determined. In systematic sampling, the selection of a sample is very convenient and is cost and time efficient. However, systematic sampling has certain limitations. In systematic sampling, the first unit is selected randomly and the selection of remaining units is based on the first unit. So, randomness of the selected sample units can be questioned. In short, the procedure for selecting a sample by using systematic sampling: Step 1. Select a suitable sampling frame. Step 2. Assign each element a number from 1 to n. Populate ion size. Step 3. Determine the sampling interval by using the formula k is equal to n. Population size, sample size. Step 4. Select a random number by using random numbers table between 1 to k. Step 5. Then obtain sample units by adding constant interval. Stratified random sampling. Stratified random sampling is an improvised sampling method over simple random sampling and systematic sampling. This sampling will have more statistical efficiency. Stratified random sampling is based on the concept of homogeneity and heterogeneity. In stratified random sampling, elements in the population are divided into homogeneous groups called strata. Then, researchers use the simple random sampling method to select a sample from each of the strata. Each group is called stratum. In stratified random sampling, stratum should be relatively homogeneous and the strata should contrast with each other. This process of dividing heterogeneous populations into relatively homogeneous groups is called stratification. In most cases, researchers use demographic variables as the base of stratification. Stratified sampling is a two-step process in which the population is partitioned into subpopulations or strata. The strata should be mutually exclusive and collectively exhaustive in that every population element should be assigned to one and only one stratum and no population elements should be omitted. The major objective of stratified sampling is to increase precision without increasing cost. For example, a company that produces perfume wants to know the consumer preferences for its newly launched product. For this purpose, company researchers have to select a sample of 1,000 consumers from a particular town with a population of 10 lakhs. This population contains people from different age groups, education, religions, etc. These groups may have different reasons for preferring a product. If we select 1,000 customers by using simple random sampling method from the population, may not lead to an accurate results because they may not be true. Representatives of the population. So, instead of selecting people directly from the population, we need to divide this heterogeneous population into homogeneous groups based on age, gender, education, profession, religions, etc. And then simple random sampling procedure can be used to obtain the samples from these homogeneous groups. The researcher has to keep in mind that within each group, homogeneity or alikeness must be present, and between the groups, heterogeneity must be present. Stratified random sampling can be either proportionate or disproportionate. Proportional stratified sampling. In proportionate stratified sampling, the size of the sample drawn from each stratum is proportionate to the relative size of that stratum in the total population. Let us assume a survey is conducted to analyze the status of employment of the recently graduated batch of students. In Karnataka, approximately there are about 180 first-grade colleges have been established. The colleges have been divided into three categories, namely government, aided and self-financing. The number of colleges in the three categories viz. Government, aided and self-financing are 50, 60 and 70 respectively. If the required sample size is 18, determine the number of colleges to be sampled from each category. Solution: to determine the number of colleges to be sampled from each category, let the total number of first-grade colleges in Karnataka be n is equal to 180. Let the government first-grade colleges be n1 is equal to 50. Let the aided first-grade colleges be n2 is equal to 60. Let the self-financing colleges be n3 is equal to 70. Let the total sample size be n. Therefore, the relationship of proportional stratified sampling is as is equal to nn. Nn is equal to 18 by 100 and 18 by 180 is equal to 0.1 is the proportional stratified sampling value. Therefore, the number of colleges to be sampled from government category is equal to 0.1 asterisk 50 is equal to 5. The number of colleges to be sampled from aided category is equal to 0.1 asterisk 60 is equal to 6. The number of colleges to be samples from self-financing category is equal to 0.1 asterisk 70 is equal to 7. Total number of sampled colleges is equal to 5 plus 6 plus 7 is equal to 18. Cluster or area sampling. If you have a population dispersed over a wide geographic region, it may not be feasible to conduct a simple random sampling of the entire population. In such case, it may be reasonable to divide the population into clusters. Cluster sampling is the sampling technique in which the population is divided into different clusters such that the members within each cluster are dissimilar, heterogeneous, in terms of their attributes. In cluster sampling, we divide the population into non-overlapping areas or clusters. It might seem as there is no difference between stratified sampling and cluster sampling. This is not true. In fact, there is a well-defined difference between stratified sampling and cluster sampling. In stratified sampling, strata happen to be homogeneous, but in cluster sampling, clusters are internally heterogeneous. A cluster contains a wide range of elements that are of good representatives of the population. For example, a fast-moving consumer goods company wants to launch a new product and wants to conduct a market study. For this, the country can be divided into clusters of cities, and then individual consumers within cities can be selected for the study. In this case, clusters of cities may be too large for surveying individuals. In order to overcome this difficulty, the city can be divided into clusters of blocks and consumers can be selected randomly from the blocks. This technique of dividing the original cluster into a second set of clusters is called two-stage sampling. Cluster sampling very useful in terms of cost and convenience. The steps to be followed to select a sample by using cluster sampling method. 1. Assign a number from 1 to n to each element of the population. 2. Divide the population into number of clusters. 3. Calculate the sampling interval I is equal to n. 4. Identify and select the numbers in clusters. Multi-stage probability sampling. The probability sampling techniques described previously are all examples of single-stage sampling techniques. Depending on your sampling needs, you may combine these single-stage techniques to conduct multi-stage sampling. For instance, you can stratify a list of businesses based on firm size and then conduct systematic sampling within each stratum. This is a two-stage combination of stratified and systematic sampling. In a large-scale survey covering the entire nation, the size of the sample frame will be too large, which leads to more time and cost of the study. In such study, multi-stage sampling technique designing a smaller sampling frame which will make the study practicable in terms of cost and time. The multi-stage sampling employs more than one stage to sample the population depending upon the reality. The combination of the types of sampling techniques to be used in the specified number of stages is unique. To sum up, by this we have come to an end of this episode. In this episode, we have learnt the 5 different methods of probability sampling techniques. They are simple random sampling method, systematic random sampling method, stratified sampling technique, cluster sampling method and multistage sampling method. In probability sampling techniques, sampling units are selected by chance and each sample has a non-zero chance of being selected. Sampling is done in research to be able to produce accurate results. Sampling techniques may be used to find representative samples to avoid bias.